Anil Kumar. Welcome to our series on quadratic relations. We are taking many word problems. In this video, we'll discuss the trajectory of a ball. 4 questions are there to discuss. It will help you to understand complete concept using different strategies. In case you want to learn from me, you can always send an email on the address given. Let us enjoy the journey of learning which leads to success. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are taking 4 examples related to the trajectory of a ball. This is a very important real-life situation for any quadratic relations related problems. In case you want to learn from me, you can always send an email on the address given. Let me first share with you the 4 questions. So they will be on your screen one by one. I would like you to pause the video, understand these questions and answer. And then I will look into the strategies to solve such questions. So here is the first question, which is: a football is thrown in the air. Its height above the ground is approximately given by h equals to 2 plus 14.7 t minus 4.9 t squared, where h is height in meters and t is time in seconds. So that will be a general statement. The only thing which will change in the 4 questions will be the equation, which represents the parabolic path of the trajectory. Now in the first question, we are more interested in just evaluating the value at t equals to 2 seconds, and question 1a part is: determine the height of the ball after 2 seconds. And B is: determine how long ball is 8 meters above the ground. So that is a very difficult question at times. How long is the duration during which the ball is above 8 meters? So we have to give the complete duration. So I hope you understand the question. Since many times students miss the points, they may give the time when it reaches 8 meters, but miss the duration, which is kind of very important to understand. Now here is question number 2. Similar question where height is given with a different parameter. So it is this time minus 1.25 t squared plus 7.5 t plus 2.5. And you have to find when will the balloon hit the ground. Can the balloon ever reach the height of 15 meters? Show work to justify. Find the maximum height reached by the balloon. Question number 3 is, as I was saying, some equation for the height, and based on this equation, we need to find this time what was the height of the football when the punter kicked it, the initial height. Find the time when it reached maximum height. Determine maximum height of the football to 1 decimal place. So normally in these questions, if there are decimal values, you will need a calculator to calculate and round your answer based on the parameters given, right? 4th question, again similar. We have some equation to represent the height of the ball, and this time we need to determine the maximum height reached by the ball and when will it reach that particular height. So in this case, it is finding the vertex of the parabola. Perfect. Also remember that in general, if we have an equation, let's write down. if we have a quadratic relation as y equals to ax squared plus bx plus c. In that case, if we equate this to, let us say, 0 and solve, in that case, the solution will be what? The formula is x equals to minus b plus minus square root of b squared minus 4ac over 2a, right? So that's the formula which we might use many times. And whenever we are talking about the vertex maximum, we are looking into this minus b by 2a, since the thing in the square root becomes 0. So that is the formula given to you to solve these 4 questions. If required, you could always factor and apply different strategies. We'll actually use different strategies to solve these questions one by one. Let's take question number 1. So I hope the concepts are clear to you. Let us begin with their solution. So the first question, we are given that the football is thrown in the air. Its height above the ground is approximately given by h equals to 2 plus 14.7 t minus 4.9 t squared. So as you know, generally, any equation in polynomial should be written with highest degree first. So we should rearrange this equation. So that should be our first step. So we should write this as minus 4.9 t squared plus 14.7 t plus 2, right? So this is in the form ax squared plus bx plus c, which is the standard form. Now part A. So let's do part A, which is question 1a. Determine the height of the ball after 2 seconds. That means t is equals to 2. So you just substitute 2 in your equation. So you get height when t equals to 0 equals to minus 4.9 2 square plus 14.7 times 2 plus 2, correct? And you can use your calculator to calculate this value. It is a simple value to calculate even without a calculator. However, I will answer these questions using calculator just to save some time, and calculation errors can be avoided, right? So I'm using calculator. We'll then round our answer. So 4.9 times 2 square, which is 4, plus 14.7 times 2 plus 2 gives me 11.4 over 5, which in decimals is 11.8. So we find that this height is 11.8 at t equals to 2 seconds. Right? Now include the units and write down the answer. So very important. So write down the solution and the answer, which is determine the height of the ball after 2 seconds. Height after 2 seconds will be 11.8 meters. You get the idea. So that is very important to write down. So answer should be written very clearly along with the units as we have written here. So I will not go into these details as we move along. However, in a test, that is kind of very important. Now let's look into part B, which is determine how long the ball is 8 meters above the ground. Let us try to understand part B of this question, right? So let's try to understand. We'll solve it in the next page. So if you look into the trajectory, you can always sketch it kind of like this. This is when t is 0, the height is 2, and then it eventually falls on the ground. So we can say that the trajectory of the ball will be something like this, right? Now clearly from what is given to us, this point is at 2. So that is your height h, right? And this is the time t. Time t is given in seconds and height is given in meters. Now, when it says how long the ball is 8 meters above the ground, you can draw a horizontal line. So this is not to the scale. Let me just break this, right? So this is not to the scale. So let us say this is 8 meters, right? I don't know really, but we can just draw just to illustrate. So it will be 8 meters sometime. We have to figure out what are these times, right? So let's call these times as T1 and T2. So the duration is from T1 to T2. That is how you have to write down the answer. You get the idea. So I hope you have understood what we need to do. You can actually pause the video at this stage. Equate this equation to 8. Height is 8, right? So this is when h equals to 8. You get the idea. That is what we're saying. So let's solve this equation now. So we want to find the duration when height is greater than 8 meters. That is what we want to find. Correct? So let's equate this. Let's find when is it equal to 8, right? So let's figure out when is height equal to 8. So that means in the equation, I'll write h as 8 and then rewrite the equation, which is minus 4.9 t squared plus 14.7 t plus 2. Now, bring h to the right hand side. So it becomes 0, right? So 0 equals to minus 4.9 t squared plus 14.7 t plus 2 minus 8. So that is 0 equals to minus 4.9 t squared plus 14.7 t minus 6. So that becomes your equation to work with. Normally what I do is I make the coefficient of t square always positive. I can rewrite this equation as 0 equals to 4.9 t squared minus 14.7 t plus 6. Since I want to work with more positive values, you get the idea. And you also remember the formula to calculate this. If we have ax squared plus bx plus c equals to 0, in that case, x is what? X is minus p plus or minus square root of b squared minus 4ac over 2a, right? So that is the formula which we are going to apply. In this case, the variable is t, and therefore, I will write t equals to. Now here, negative of 14.7 will be 14.7 positive, right? Plus or minus within square root 14.7 square b square minus 4 times value of a is 4.9 and value of c is 6. Correct? So that is what we get divided by, so this is within square root, 2 times a, which is 2 times 4.9. So let's see what it gives us. 14.7 plus minus. Let's figure out the square root thing. So b square, 14.7 square, minus 4 times 4.9 times 6. And that gives us a value which is 98.49. Within the square root. So almost 10, right? Divided by 9.8 when you do the denominator, correct? Now let's square root 98.49. So I'm going in small steps, which is kind of very important for anybody to understand what is going on here, right? So we get 9.92 as this value. So we get t equals to, so let me write, t is already there. So let me write this as, let me write here. So t equals to 14.7 plus minus 9.92. Now it says most of the units are like 2 seconds and 8 meters, and where h hits this ground, it doesn't say approximately given by this. So how many decimal places? So we'll do 1 decimal place. Is it okay? So I'm using 2 decimal places here, and then we'll work out this solution. So we can get 2 values from here. One is 14.7 plus 9.92 divided by 9.2, and the other one 9.8, sorry. Denominator is 9.8, approximately 10. And then 14.7 minus 9.92, right? So let's add 14.7 divide by 9.8. So we get one answer, which is 2.51. So let me round it to 1 decimal place, 2.5. The other one is 14.7 minus 9.92, and then equal to, and then divide by 9.8, right? Put the numerator in brackets. So we get 0.48, right? So very early on, it moves on to 8 meters. So that becomes the duration, right? Now, so, and this is in seconds. So we can now answer the question that the duration for this particular case is from 0.48 seconds. I'm writing 48. We could run it to 0.5 seconds also, to 2.5 seconds. So let me round it to 1 decimal place, right? So from 0.5 seconds to 2.5 seconds. That is the answer for part B. The ball is above 8 meters from the ground. You get the idea. So we get these times as 0.5, and that one was 2.5. So this is kind of very important sketch which helps you to visualize the situation. So whenever you solve these problems, try to sketch, visualize, and then solve. Perfect. So I hope it gives you a lot of concepts. Let's move on to question number 2. Now in this case, a water balloon is catapulted into air from top of a platform. The height h in meters of the balloon after t seconds is h of t is equal to minus 1.25 t square plus 7.5 t plus 2.5. When will the balloon hit the ground? Can the balloon ever reach height of 15 meters? Show your work to justify. Find the maximum height reached by the balloon. Now, these two questions relates to completing the squares, right? The first one is when the balloon hits the ground. So let's answer question number 1a now. Hits the ground means what? Hits the ground means height becomes equal to 0 because the height is measured from the ground. So we can equate 0 equals to minus 1.25 t squared plus 7.5 t plus 2.5, correct? And then find what t is using the quadratic formula. You get the idea, right? So that is straightforward. You can use quadratic formula. Okay, so I prefer to make the leading coefficient positive, so I'm multiplying by minus. So I'll write this as 1.25 t squared minus 7.5 t minus 2.5. Do you see that? Since I want to keep the leading coefficient positive, right? So that is kind of a note. Right? And then we'll calculate using the formula itself, and the formula is t equals to minus of b. So see, it becomes positive 7.5. You see that part. Otherwise, if you use the old equation, the previous equation, we are working with a negative value. Sometimes using calculator, you may miss that minus and get a wrong answer, and it will create a lot of confusion. So this is actually a practical step. So not really required, but ensures better results. So 7.5 is minus of minus 7.5. Minus b plus minus square root of b square means 7.5 square minus 4ac. 4 times a is 1.25 and c is minus 2.5. So that will make 0. That is a 0, right? 2 times 1.25. You get the idea. Now let's rewrite this. So we have 7.5 plus minus square root of 7.5 square, and that minus and minus makes it positive. You get the idea. Positive 4.1.25 times 2.5 over, you can multiply this, you get 2.5, correct? Use calculator to find this particular answer. Okay, so let's work out the square root part first, which is 7.5 squared plus 4 times 1.25 times 2.5. And that gives you 68.34. We'll square root our answer, and that gives you 5 square root 11 by 2, right? We'll add this to 7.5. You can do all this in a sequence, and then you divide by 2.5. And what you get here is 3 plus square root 11, which is approximately equal to 6.316. We'll round it to one decimal place, 6.3 seconds. You get the idea. So that is how we are going to calculate this using the calculator in one shot. So you just work out the value using the calculator as I did, right? So within the square root, work out 7.5 square plus 4 times 1.25 times 2.5 square root, and then add 7.5 because we want the value on the right hand side, which is positive, and then divide by 2.5 and write down the answer. So the balloon hits the ground when at 6.3 seconds, right? So that much time it takes to hit the ground, and that is how we are going to answer, right? So that becomes the answer. Now let's look into the other parts of this particular question. So it says, can the balloon ever reach a height of 15 meters? Show your work. Find the maximum height reached by the balloon. So it's better, because we have to show the work, to do the completing the squares itself, and that will answer part B and C both, right? So we will do completing the squares method. So we'll actually use completing squares. We have the equation as h equals to minus 1.25 t squared plus 7.5 t plus 2.5. To complete the squares, we'll take minus 1.25 as a factor, right? We want the leading coefficient to be positive 1. So we're left with t squared minus 7.5 t divided by 1.25, correct? And we are going to keep this 2.5 away. from this particular bracket. And now we have to do half of this value and add and subtract. So we have minus 1.25 t square minus 7.5 over 1.25 t, and the half of this value will be 7.5 divided by 2.5, correct? So that is the half of this value. We can square this and we can subtract the same value. You get the idea. I am not calculating this for now. We'll just do it at the end, right? Plus 2.5. And now we'll open the bracket. So when you open the bracket, you get minus 1.25. And within the bracket, the first three terms makes it a perfect square, right? That was the completing the squares method. And that gives us t minus from here. And we have 7.5 over 2.5, right, whole square. And then multiply this with the other factor, right? You can see 7.5 divided by 2.5 is 3, right? So it's very easy calculation. So I did not do any calculations earlier. And you can see it is, dividing by a quarter. So it is 3. So I could write this as minus. This minus and that minus becomes positive, and we can have this value. So let me rewrite this as 1.25 times 3 square, right? So I'm just writing 3 square, we'll calculate later, plus 2.5, correct? So that becomes the answer hidden in this equation itself. So that gives you two parts. Time is given here, and that is your maximum height, correct? Those are the two things. So let's figure this out. So now, from here, what is the time? So from here, we know t is equal to 7.5 over 2.5, which is 3 seconds, correct? So that is the time. Find the maximum height reached by the ball. We have to figure out, can the ball ever reach a height of 15 meters? Show your work. So at t equals to 3 seconds, it reaches the maximum height. But how much it is? Maximum height is how much? Maximum height is this component, right? Which is 1.25 times 3 square plus 2.5, correct? So let's calculate this. So that is 9, right? So let's use calculator if required. 1.25 times 9 plus 2.5 and gives you a value which is 13.75. And this value is in meters. But the question wanted to check if it ever reaches 15 meters, correct? It doesn't reach that. So maximum height is 13.75. You can write down this as your answer for part C. Find the maximum height reached by the balloon. Maximum height is 13.75 meters. Is that correct? That is how you'll do, right? So part B is, can the ball ever reach a height of 15 meters? Answer is no, it will never reach a height of 15 meters. And the reason is all this. You get the idea. And for question 2C, we can write this as 13.75, the maximum height reached by the balloon, water balloon. So we're talking about this water balloon. Is that clear to you? So I hope all the steps are absolutely clear. Let's move on and take the next question. Question number 3. Now in this case, the height h of the football in meters, t seconds since it was kicked, can be modeled by h equals to minus 4.9 t squared plus 22.54 t plus 1.1. What was the height of the football when Punted kicked it? Now that is when t is equal to 0, right? So in our equation, which is h equals to minus 4.9 t squared plus 22.54 t, the first two terms become 0 for t equals to 0, right? So if t equals to 0, in that case, height is equal to 1.1 meters. So that is question 3a, right? The initial height. Now let's look into part B. Find the time when it reached the maximum height. Determine the maximum height of the football to one decimal place, right? So again, you can use the quadratic formula to do it. Here, we will use alternate method, right? So, of course, you could use quadratic formula. Right? You have this particular equation. So, you can find the time when it reaches the maximum height. It is reached at minus b by 2a. If the equation is y equals to ax squared plus bx plus c, then maximum is at x equals to minus b by 2a. Do you see that? So this is what the formula says, and you can plug in minus b by 2a. So in this case, the time will be what? If I use the formula directly, it will be minus of b is 22.54 divided by 2 times a, which is minus 4.9. You see that? So that gives you the time when it reaches the maximum height. So basically, we are saying we have to calculate 22.54 divided by 9.8. So 9.8 is acceleration due to gravity, and therefore most of the questions will have that number. So 22.54 divided by 9.8, you can estimate always using 2. This 9.8 as 10, right? So what you get here is 2.3. So determine the maximum height. We know the time now. Find the time when it reaches the maximum height. The answer is t equals to 2.3 seconds. You get the idea, right? Now you can plug in 2.3 to find the height. So h equals to, plug in 2.3 now. So minus 4.9, 2.3 square plus 22.54 times 2.3 plus 1.1, correct? Now you can calculate this. So we already have, so we'll do, I prefer to do positive things first. So 1.1, I'm going reverse order, plus 22.54 times 2.3 minus 4.9 times, it's better to put this in brackets, 2.3 squared. And then we write equal to, we get 27.021, which is approximately equals to 27 meters. You get the height. So the maximum, they say one decimal place, so we'll have to write 27.0 meters. You get the idea. To one decimal place. So it's important to write 0.0 in this particular case, since that has been asked for, correct? So the maximum height reached is, write down the complete statement and then the answer, 27.0 meters with the units. You get the idea. That is how you should do it. And this is the shortest way to answer the questions. Perfect. Now, let's look into the last question here, which is, a baseball is hit from the height of 1 meters, and therefore you can relate the 1 meter in the equation itself. If t is 0, we have 1 meter, right? Let me highlight once again. So hit from the height of 1 meters, and therefore you have this plus 1. T equals to 0, you get 1 meters. Now, the equation is given by h equals to minus 5.5 t squared plus 90 plus 1. Write down the equation. We have rounded 4.9 to 5 in this particular equation, right? Okay. Now it says, determine the maximum height reached by the ball. When will the baseball reach at the maximum height? So here I want to discuss with you alternate method, right? So you will see in our solution, what did we do? Well, we use quadratic formula in this case, right? So we use quadratic formula. And then in the next solution, we again use the quadratic formula. And then we worked with completing the squares method also. So we have used completing the squares method. We are now going to use the third method, which I call partial factoring. So I'll solve this question with a strategy, partial factoring. This could be a new method for many students, but it's very effective. Now let's see how do we figure this out. So we could actually write this height as we can take just t common, right? So let's take minus t common. In that case, what do we get? We get 5t plus 9 here, right? And here we have 1. So look at it in this fashion, that if time t is 0, or, right, so this will be minus 9, right? So because I took minus common outside. Okay. So you could also write this as like this. You could take 5 common also, right? So if I take minus 5t common, I actually get t minus 9 over 5. Does it make sense? Plus 1. Anyway, so we did partial factoring. So we took minus 5t. It's up to you. So what you notice here is very important thing, that at t equals to 0 and at t equals to 9 by 5, what is height? Height h is equal to 1. Same height, right? You get the idea? Same height. So axis will be right in the center, right? So axis will be average of the two, which will be 0 plus 9 by 5 divided by 2. So the axis will be 9 by 10, which is 0.9. Correct? You understand this? I'll explain you. So what I'm doing here is, let's say that the path of this ball is kind of like this. Let's draw it. Correct. So what we figure out here is that there are 2 points which are giving height of 1 meters, right? So those 2 points are at t equals to 0 and at t equals to 9 by 5. So if you look at it, you find that these are the 2 points at 0 and at 9.5 that we have the same height of 1, right? So that means right in the center, midway between them, we have, this is the axis we are talking about. And this axis should be midway. So where will it be? Well, this was 9 divided by 5. So that will be 9 divided by 10, half of that. That means 0.9. You get the idea. And on this line, we have the maximum. So if I plug in this, we'll get the answer. You get the idea. Which is same as minus b by 2a, right? So let's look into this now. I hope you got the concept. So let's again work on this. We are given the equation, which is h equals to minus 5t squared plus 9t plus 1. So we factored out minus 5t and we get t here and minus 9 by 5 plus 1. Now the axis is at half the value, which is at t equals to 0, which comes from here, and then from there we get plus 9 by 5, everything divided by 2. So at t equals to 9 over 10, which is 0.9. So when will the baseball reach its maximum height? At t equals to 0.9. 9 divided by 10. Now you know this, plug in 0.9 to find the maximum height. So h will be minus 5, 0.9 square plus 9 times 0.9 plus 1, which is, is 81. So minus 5 times 0.81 plus 9 times 9 is 8.1 plus 1, correct? Multiplying by 5, so 5 times 1 is 5 and 40, so we get 4.05 plus 9.1, and that gives you 9 take away. 9.1 take away this means 5.05. Is that clear to you, right? So in meters. So that becomes your maximum height. You get the idea. You will also note that T could be worked out as equal to minus b by 2a, which is minus 9 by 2 times minus 5, using the formula that x equals to minus b by 2a when you have a standard equation. You get the idea. So you could use that also. But anyway, that becomes the maximum height in the given case. So what you notice here is that we did solve these questions, right? Question number 1, which was using substitution, t equals to 2, and then we worked out the times using the quadratic formula, right? And then got the answer. Then in question number 2, we again used the quadratic formula to find the duration. And then in question number 3, we worked out the maximum using completing the squares. And then we worked the fourth equation using partial factoring. So we have used different strategies to solve these questions. Perfect? I hope it makes sense. This is very important topic. Whenever you study quadratic relations, there will be a question based on what we have just done. I hope it really helps. Feel free to write your comment, share your views. If you like and subscribe to my videos, that will be great. Thanks for your time and all the best.